All right. Good morning, everyone. My project was doing electron-based dissociation of fluorescently derivatized glycans using Fourier transform ionocyclotron resonance mass spectrometry. The goal of this project was to use a novel tag to promote structurally informative fragmentation and electron-based FTIR methods on glycans. So what are glycans? Glycans are complex sugar structures made of individual simple sugar molecules typically found on the outsides of proteins, lipids, and other biomolecules. They play an important role in cell signaling, cell communication, and protein functions and interactions as a whole. The structures of glycans can be altered when introduced to disease and especially cancers. So having robust methods to be able to define the structures of these glycans is very important. One of the ways we are able to define these structures is by using tandem mass spectrometry. So this allows us to analyze a molecule based on its mass per charge ratio whilst in the gaseous ion phase. And when we introduce electrons to these ions, we're able to promote different forms of fragmentation. So we have our glycosidic cleavages shown here. These are our B and Y and C and Z fragments, and these separate the sugars along the glycan chain. And we also have our cross-ring fragments, which are our A and X fragments, and these cleave the sugars themselves and give us more information about branches, linkages off of the glycan. The glycan I'll be focusing on for this presentation is LS tetrasaccharide B or LSTB, which is with the structure shown below. So to enhance these fragmentations, we use fluorescent tags. We had 2-aminobenzamide or 2AB, 2-aminobenzoic acid or 2AA, 9-aminophorine or 9FL, and aminopyrene trisulfonic acid or APTS. These are referred to as fluorescent tags because of these aromatic 6-carbon ring structures you see throughout them. These give them fluorescent properties, and especially in the case of APTS, it was visibly a bright fluorescent green. On the right, this is the 9.4 Tesla FTICR mass spectrometer we use for all of our analysis. So the results of this project, we found that the 2AB molecule actually produced the most amount of fragments when compared to the underivatized glycan and all the other tags. On the right, these are two spectra, the LSTB underivatized on the top and the APTS tag on the bottom. Even though there were less total fragments produced in the APTS, we did see more unique fragmentation, so different fragments that we weren't able to see before. And in conclusion, the 2AB tag did enhance fragmentation the most when compared to the underivatized and other tags, but the 2AA, 9FL, and APTS did show improved unique fragments in our electron-based methods. We also looked at the glycan lacto N-fucopentose, or LNFP, to confirm that these results were reproducible. We also gather a lot of data on LSTA and C, which are isomers of LSTB, so it'll be interesting to take a look at those as well, and to assess the usefulness of this derivatization and other fragmentation techniques, such as collisional activation. I would like to thank my mentor, Christina Hackinson, and Stephen DeFilia, who I worked very closely with this summer, and the ICDR department as a whole for having me. Thank you.